All right, we're back. We're doing session 5.1. We're talking about node fundamentals and the event loop. And the event loop is pretty famous in Node.js. If you don't know, we're going to talk about that. So we're going to talk about fundamentals 2. Again, continuing on from fundamentals 1. But we're going to be talking about the asynchronous nature of Node.js. Why it's such a big deal. Because mostly it has this thing called the event loop. We're going to talk about what that is and why it's so different in terms of server-side development. So asynchronous code, libuv, event loop. These are the inner workings, the main the main thing that Node is one of the main things Node is famous for, right? The what makes it non-blocking versus blocking code. So let's take a look at this. So the event loop is what allows Node.js to perform non-blocking I/O operations. Since most modern kernels are multi-threaded, they can handle multiple operations in the background. So what that means is if you look at some other types of server-side frameworks in the past, or kernels, right, runtimes, they were multi-threaded. And if you ever had to work with multi-threading and some of this stuff, I'm telling you, it's not fun, right? You would have to actually spawn off threads, try to lock threads, uh, fight for control of these different types of threading, keep track of them, and do things on there. And it's really can be really complicated, right? I mean, I know with .NET framework and all these things later on, they came up with things like the parallel library and different types of task based libraries again, but those are not built into the whole baked in, right? So Node.js underneath the package is handling this. You don't have to manually go and make things asynchronous. It is asynchronous by nature. So it's already part of the whole runtime. So you don't really need to worry about that. So it's really powerful in that sense. So we kind of often equate it back to the browser. The event loop is constant. So there is a concept of an event loop in the browser that's constantly listening for DOM events like key presses and mouse clicks and all these things. And again, we talked about how the creator of Node.js, Ryan Dahl, just said, hey, let's just take a unique approach to the server side. Let's treat the server side as we would the browser does. The browser is so responsive and event driven. Why not take that same approach and apply it to the server paradigm, which was pretty innovative at the time. So if we dig deeper and we look inside the event loop, basically the event loop it's not entirely a queue, but for the diagram right there is actually simplifying what it is. But for our first introduction to it, we're gonna visualize it like this. So basically, the event loop is constantly listening for events on the server side. So so it's gonna basically offload things. So if we talked about callbacks, right, and these kind of things, and timers and all this types of things, they can be deferred until a later time, right? So if you have some execution running on the main thread, the single thread, some high consumption file download, you know what? That can be offloaded and deferred to the event loop. So when that finishes, then the event loop will look at that. I'm getting ahead of myself here, but basically it's constantly looking on this queue and for events on there. So when we're talking about events, these events can be externally generated, like an HTTP request or a TCP connection coming in. So that could be an event, right? Those events usually have callbacks. Or they can be internal events. So we're internal events like timers, set intervals, and things like that. So these events will be placed on the event loop, but they may have deferred callbacks or executions, right? That basically can be processed at a later time. So basically, it allows the server to be open and responsive to many different types of requests coming in, and we're not blocking anybody. We're basically handling one, deferring it if we need to, handling the next one. So basically it can handle subsequent concurrent events coming in, also external and internal events that may be going on. So it's constantly cycling through. And when we get into more advanced features of the event loop, we'll know why it's not considered truly a queue. So other events may be triggered as a result of a response to an external event. So for instance, if a timer happens to go off, right, um, it triggers a file system to maybe open and close a file. So we have an event that may be happening on when the file is read based on when it's closed. Maybe a TCP connection comes in, some process kicks off, another HTTP request comes in, maybe a request for a page, from a web server, from the web server. Meanwhile, internally things are happening in behind the scenes and other events are being triggered. So requesting Node to open a file for reading will trigger an event when completed. Again, all these events will be handled asynchronously. Like I'm trying to get at is when these events occur, they may be offloaded, the callback execution may be deferred till another time because you may have executed an event such as I'm going to open a connection to the database and I'm going to run a very long query. Maybe that query might take an hour. Who knows? Could be over a million records. But I'm not going to hold up the main thread. I'm going to offload that until until I have an event listener that say that query has returned or has finished executing. At that point, on that event, which is maybe query has completed or database connection closed, I'm going to trigger something else, right? So I don't need to hold up resources waiting for an hour for that million query to go through whatever it needs to go through and compute and come back. I can basically kick it off, park that piece of logic and wait until it's finished and then keep serving up other types of requests that may be coming in. When in fact that query does return, it could be an hour, it could be who knows when, then I'll execute whatever function, whatever logic I need to have happened after that. It could be another event being triggered, it could be some other cleanup, whatever have you. I don't synchronously need to hold up the server and wait for that like what would happen in other types of runtimes. I am free to asynchronously handle more calls and offload them and defer them for another time. So here's an example of a web application for a non-blocking approach. So an application raises an HTTP request and it triggers an event to read a query from the database like I was talking about. So if you can see that database, that response may take time, but at the meantime, another request comes in. And maybe there's some other type of long-running query that might happen, but again, it doesn't tie up the first request. It allows the server to handle the second, and in parallel or concurrently, it can just handle both of those requests. And concurrently, it can also access the database and run whatever transaction it needs to run. So once Node receives an event from the database is complete, it sends back the response. So the response comes back asynchronously. While waiting, Node is not blocked. That's the main thing. It's not blocked. Non-blocking I/O. It's free to take as many requests as it can handle, and basically that's the power of the event loop, right? It's concurrency, it's non-blocking, it's asynchronous. So basically, here's another example of what this might look like. So here's kind of another simplistic view, again, just to visualize what's happening. So we have requests coming in. Again, remember this, and it's key to remember is that the node.js server runs on a single thread. Single thread. Now, when we talk about Node and why it's called Node, it's because Node can scale. So although it's single threaded, it can actually be scaled multiple times, like multiple instances of itself. So you could have as many CPUs as you have. You can have different node instances and scale it that way. Each of them have a single thread, but they're scalable and they're different instances. So that's how you can scale it that way. So don't be fooled by the fact that it's single threaded, but know that the event loop is single threaded. So getting back to this, we have a request coming in. We have this event loop. We register a callback, and the event loop is constantly So the event loop is constantly cycling and looking, but it has this internal kind of queue where all the callbacks get registered. So it registers a callback. There could be a file system update operation. It could be a database transaction. Could be some very big computation. The event loop is constantly looking for when one of these callbacks returns. When it picks up the operation has completed, it triggers that callback and then executes whatever it needs to execute. So if you think about all those file system, database, and computations, they have events on it. Maybe event would be the file has opened, or it's about to be read, and then you may have an operation when it completes that it has completed being read, or the transaction has just started, or the transaction has completed, something like that. So basically, the point is you get an update when the operation is completed, and it fires triggers, right? It emits events. When we were talking about event emitters, we were talking about how event emitters we can register listeners, and we can trigger those things. So we register a listener with a callback. When that event is finished or triggers that listener, makes then the callback gets executed, right? So we have the concept of listening and emitting. When something is emitting, triggering something completed, that the listener will catch that and then execute the callback function. Again, event-driven architecture, event loop, events, event emitters. This is all baked in. This is we need to start thinking in this way when we're talking about Node.js. It's a very uh, far departure from how we would normally think. We just have to think of server as we would like the client, right? We have a lot of interaction in the UI. Now we have a lot of interaction in the server side. So async IO. So the following tasks should be done asynchronously using the event loop. Heavy IO operations, right? Heavy computation, anything that requires blocking. So very big operations like streaming a huge file, dealing with big data, dealing with heavy computation, right? We might have some type of we might have some data coming back from MongoDB that could be something like DNA matching, where you have to do some very complicated complicated computation on matching DNA markers, right? I'm talking about that because I actually went into an interview where they were doing this, and it's very heavy computation. You would need something like Node.js to like fire off processes to go and handle that. At the same time, be very responsive for other requests coming in. So that is what should be done asynchronously. We talk about async IO. That's what we mean. Asynchronous versus synchronous programming. If you don't know, synchronous, this is what it looks like on the left. You have a client make a request. Could be a request for to, I don't know, view a movie on Netflix, right? The server goes and basically it goes and loads, and you get that spinning wheel, and we're waiting and waiting and waiting until it's like all ready to play. We tie all the resources up. We tie up any response coming in will be very slow now to be handled, or they'll have to wait. And then finally, when it is ready to stream, it returns a response, right? Asynchronously, as you can see right here, the request comes in for that content to be streamed. Netflix, I don't know, you're going to watch something like Spider-Man 3. I don't know what's out now. Who knows, right? Everything's canceled right now. So make a request, and it goes in the background and it starts to stream that big video. At the meantime, it's not holding anything up because it's deferring that big streaming as a callback to the event loop, and then it can continue working and take many more requests. When that big file, whatever it is, I don't know, maybe you're a DC fan, maybe it's I don't know, the new whatever, right? Batman Returns. Batman Returns is ready to stream. It comes back with a response, and then finally it comes. But in the meantime, asynchronously, other responses have come in, requests have come in, and responses have gone out. Maybe something as simple as, hey, just log me in. Anyhow, asynchronously allowing the clients, multiple clients, or the same client to make multiple requests and concurrently serve him. So when we keep talking about a callback, right? So a callback is a very confusing concept. If you're new to programming or you don't know what it is, it's basically a way. It sounds like what it says. A callback function is something to be executed after another function is finished executing. hence the name callback. So I like to say deferred, right? So when we have something that needs to happen, we can defer it till later. When that has finally completed, then we execute that deferred functionality, but we call it a callback, right? So call back to sender, return to sender. So an event is like a broadcast, while callback is like a handshake, right? So we broadcast the event, and then we defer the handshake until we know the deal is done. When the deal is done, we shake the hand, right? We sign off on it. That's kind of like what it is, right? It kind of seals the deal. But we don't seal the deal until we know the deal is done, right? It's business, right? So a component that raises an event knows nothing about its client, while a component that uses a callback knows a lot about it, right? Because again, we're dealing that handshake. We know who the sender is. We know who the listener is. We know a lot. We don't just randomly fire events, fire and forget. We don't do that. We actually know who the sender is. Asynchronous versus synchronous code. So this is what synchronous code would look like, and this is what I'm trying to get at. When you open a connection, it basically waits until that connection is granted. Okay, and then when you do a statement, connection.create statement. Okay, those two may not, depending if the connection comes back or not. You never know. It could be an error in there. The result, when we run an execution, right? If you were to debug this, it will sit there and execute that query, and it will wait until it returns. If that is a long-running query, you are stuck there for however long until that query returns. If it fails and the transaction rolls back, if you're not catching the error, you may be waiting for a very, very long time. If ever it comes back, it may throw an exception and you can't catch it. Compared to asynchronous code, which looks like this, now this is non-blocking. If you look at how this, again, it looks familiar. It kind of looks like our event emitters, right? How we wire up events, which again, in Node.js, almost all a lot of functionality, a lot of classes, a lot of built-in, baked-in modules always inherit from event emitter. So you're going to see this pattern a lot. We go get a connection. We have the connection string. We have a callback. Callback number one. Error first callback. If you notice in there, there's function ERR. That means error. And then CON is short form for connection. So we have a callback. When we execute that callback, again, it grabs the connection, defers it. When it comes back, the handshake is complete. I got the connection. Then I can create the statement. When I create the statement, I have another callback. I can have another callback basically. And when it returns, then I run the long running query. So here is an example of two callbacks and a synchronous call. But I could also turn around and execute query with a callback as well. So basically what it's saying is it just keeps going, right? The first connection comes back, I do a callback. The query comes back, I do a callback. So in any of those transactions, the server is free to continue, regardless of what happens, right? If the error gets thrown inside of the connection, it does not affect the main thread. It is deferred. So that's what asynchronous code looks like. Timers. So we've used timers quite a bit. And basically, we're playing around with timers a lot because this is how we need to think. We can have, it's all built into the node built-in modules. So timer module exposes a global API for scheduling function calls to be called at some point in the future. So we can take something that may be synchronous, but then add a timer on it to say, delay it until the future sometime, maybe 5 seconds from now, maybe an hour from now. We can defer things even further, and we can schedule them late, in the future, right? There's no need to require timers because the timer functionality is built in as global. But if you're used to working with JavaScript on the browser, we know that timer and set interval is already part of the browser and that web API. But Node took a step further and said, hey, we don't need to include this. We're going to make it part of the global API. We're going to include it. It's built in, right? But again, remember the JavaScript that we're using is syntactic sugar, right? Because when it compiles down, it'll internally know what timers means. Because again, Node at the internal level is C and C++, right? And then it transpiles down the JavaScript using the V8 engine, It transpiles down, even though you are using timers, right? As you would think of in the browser. It truly is not a JavaScript timer. It gets transpiled down to the equivalent C and C++ and all of the other core modules, which then compiles it down further to machine level code, down to instructions that the CPU understands, right? That's what we are doing server-side code with JavaScript. JavaScript is meant for the client browser, but we are doing JavaScript in our head. We think we are doing it, but internally what happens is it gets transpiled down to something that we don't see, right? We don't see all of that. We just assume I know JavaScript, I'm using Node, and that's the beauty of it all, right? That's the beauty of it. We're pretending, we're not pretending. We basically are continuing on in that full stack using JavaScript all the way through. How convenient, right? So Node.js and web browser timer functions implement the same API. However, Node.js uses the event loop to achieve it, right? Internally, it's using event loop, C and C++ and all that stuff, but at the very high level, we're just using a timer. Well, hey, it's a JavaScript timer. It runs the way we expect it to run, but internally it does a lot more. Another built-in feature when we're talking about timers is set immediate. So set immediate schedules the immediate execution of the callback after. So schedules the immediate execution of the callback after event calls back. All right, I'm actually I'm actually getting tied up with my own slides here, but it runs immediately, right? Set interval, the one we can basically have a callback and a delay. So this is different than set timeout. So set timeout defers something to the future after 5 seconds. Interval basically calls the same callback, repeated execution of the callback every delay. So if you have a set interval here, and you have the Macho Man, and he says, "Oh yeah, I'm the Macho Man," it's going to keep going and going and going for every second until you clear that timeout, that interval, or it just basically runs indefinitely until it runs out of memory, right? But basically, you should be cleaning up your timers. That's another thing to worry about when you're not to worry about, but be aware of when you're kickstarting a timer. Sometimes you may need to clear it, right? You need to clear the timer so it doesn't keep running. Set timeout is the one we've been talking about a lot. So it schedules execution of one-time callback after delay, right? Interval has multiple callbacks. This is just one after a certain delay. And one note is there's no guarantee that a callback will be triggered exactly after the specific time. Instead, the callback will be called as close as possible to the time specific. Because remember, we're going through the event loop, right? And the event loop may be aggregating a bunch of other types of callbacks. And there's a concept of every time it goes around that circle, in actuality is called a phase or a tick. And when it's going to the next phase, it's going to go and clear things out accordingly. So just be aware of that. Hey, what runs all of this is this thing right here. This raptor, this velociraptor, right? I can't make this stuff up. libuv stands for Unicorn Velociraptor Library. I don't make this stuff up, folks. This is just what it is. Who says programmers don't have sense of humor, right? Just look at that, and that's the logo. So this is the multi-platform C library that provides all of that asynchronous I/O that the event loop is based on, right? This is another core feature. If we go back and look at the architecture, this is one of the pieces that is right beside the V8 engine that is internal to Node architecture. This is what makes this whole asynchronous, great stuff, event-driven architecture all work. So this is, again, looking at this libuv architecture. If we're just looking at this module, this is what it is. This is what it is known for. This is what the architecture is built on. It's the operating system. It handles network I/O. So we're talking about TCP connections, HTTP connections, these kind of things that we're going to talk about in socket I/O, and we talked about the web server file I/O. So when we're dealing with files, we're talking about deleting files, creating files, opening files, writing the files, all that type of stuff. Other stuff, all right? OS independent stuff, all right? So that's kind of generalizing a bit, but just know this thing encapsulates a lot of those POSIX operations. And if you remember Unix and all that stuff, a lot of the commands will make sense to you, right? When you're talking about, deleting a file or piping streams and these kind of things, this is what is basically baked in the Node.js framework, runtime, and know that libuv is a major part of it. Again, just going back to this bigger picture now, because we talked about libuv, it's just another way, because now we've mentioned these key features here. So we have the V8 engine, and we have the code, right? Node.js callbacks are registered, events are registered. We have this queue. Again, it's not really a queue, but we'll basically, for this diagram, we'll suspend reality and say it's a queue. So what happens is if requests go into the OS, the operating system, who knows what can happen there, heavy computation event comes back. In that queue, the event libuv is triggering this event loop, asynchronously handling those callbacks, sending it back to the V8 engine, code going back that way. So very simplified version, but the whole purpose of this session was to just talk about the asynchronous nature of Node.js, introduce that, introduce timers, callbacks, introduce the concept of the event loop, and then the various pieces that we build upon with Node.js. And that's one of the major fundamentals of Node.js that you need to know about.